Now this one's going to be the whole, us doing all the calculations. The temperature is actually kind of important here. So it's 250 degrees Celsius. We've got carbonic acid decomposing into carbon dioxide and water. And notice that I'm giving you guys the K value. And we also have initial concentrations of 0.4. And that goes for everything. So everything has a concentration of that. So there is our equation. And I do want to point out that water is in the gaseous state here simply because it's at 250 degrees Celsius. So we're going to be able to use all of these things in our Q statement. So there is how we're going to calculate the Q. We're going to plug in all of the 0.4s, and we got one on the top, one on the bottom, meaning our value is going to be 0.4. So now that will allow us to compare the Q at 0.4 with the K value, which is 5. So therefore, K is greater than Q, right? 5 is greater than 0.4. So this one's going to proceed to the right. So it's going to proceed in the products direction here, which means these are increasing and this is decreasing. So we do need to indicate this in our ice chart. So here's our ice chart. There's my equation up top. So our initial concentrations are all 0.4. And here's our changes. We've got our minuses and our pluses, and then there's our net. So once again, we'll take our K expression here because now we know K. We're done with Q, we're on to K. Our K was given at 5. Okay, so just notice here we've got this value down here, and then each of these ones here are up top. And now we're going to need some algebraic skills. When you multiply this out, so all I've done is I have FOILed out the top here, and that gives us that stuff there. And here we have cross-multiplied these two values against 5, giving us 2 and minus 5x. Next step is just going to be to rearrange everything, collect like terms. There we go. And now we need an x value. And we got a problem here because this one's a little complicated. It's got a square value, which means we're going to need to use the quadratic formula. Now, frankly, I don't care how you do this. So what you can do is you can simply Google a website that will do the quadratic for you, like this one here. And you can see I have typed in the values that were given, the 1, the 5.8, and the negative. And I've hit calculate, and I get 2 answers. Well, the fact is that my negative answer doesn't really make any sense. My positive answer is what we want. So we've got a positive value here of 0.3. So we can go back to here and we can sort of finish off our question now. So therefore, our carbonic column is 0.4 minus x. So 0.4 minus 0.3 gives us 0.1 molar. So there is our concentration of the carbonic acid at equilibrium. And the other two are going to be the same, if you will, because they're the same numbers. So we've got an addition one here. So this one's 0.7. So because water has the same numbers, it also has a concentration of 0.7.